So far, we have completed the 2 units from the paper 1, real analysis 1 and real analysis 2. Today we shall start one more unit from the paper 2, which is about the differential equations of first order and higher degree. That is, we are going to study about the differential equations of first order but higher degree. So far, we are familiar about the differential equations, and so far you studied about those differential equations which are of first order and first degree. First order and first degree. Then, which equations are considered the differential equations of first order and first degree? Those differential equations which involve only dy by dx. That is, there is an dy by dx term. That is only dy by dx term. Such equations are considered as the differential equations of first order and first degree. First order and first degree. Since we have the term dy by dx, which is of the first order derivative. Dy by dx is first order derivative, hence it is called first order, and the power of dy by dx is 1. The power of dy by dx is 1. When the power of dy by dx is 1, then that equation is called first order with first degree. First order with the first degree. And so far you have studied about the differential equation which are of first order and first degree. Also, you know the different methods to solve the differential equation of first order and first degree. There are so many methods. For example, separable or variable, homogeneous, non-homogeneous, linear differential equation, exact differential equation, all these are methods to solve the differential equation of first order and first degree. To solve the differential equation means we have to find its solution, and solution is nothing but the relation between the dependent and independent variables along with the constant, and the solution is a relation containing x, y and a constant, which is called the solution of differential equation, and so far we are familiar about the first order and first degree differential equation. Now we are going to consider those differential equations which are of first order. Which are of first order means that differential equation containing dy by dx term. That differential equation containing dy by dx term means of the first order, and higher degree. Higher degree means that the power of dy by dx is greater than 1. The power of dy by dx is greater than 1, and hence the differential equation containing dy by dx with the power is greater than 1. At least in that equation there is one dy by dx term having the power more than greater than 1. Greater than 1 means either 2, 3, 4 or 5 and so on. Such equations are considered as the differential equation of the first order and higher degree. means equation containing the power of dy by dx is greater than 1. For example, consider the differential equation which is of the form a naught dy by dx raised to the power n, and hence this equation containing the term dy by dx which is of the first order derivative. And now you observe the powers of dy by dx. Here the power of dy by dx is n, here the power is n minus 1, and so on. Means whatever we have the powers of dy by dx in this equation which are greater than 1, and hence when the powers are greater than 1, at that time that equation is called a higher degree. And hence we have the equation which is of this form where a naught, a1, and so on an are either functions of x and y or constant. In that equation, the coefficients of dy by dx term either the functions of x and y or the constant. Such type of differential equation is called the differential equation of first order with higher degree. That is, the power of dy by dx is greater than 1. At that time, it is considered a higher degree differential equation. Then we have to solve the differential equation of first order and higher degree. Means we have to solve such type of differential equation. Then to solve such type of differential equation, we are going to use one standard notation. We are going to consider one standard notation, and the standard notation is that whatever we have the derivative term dy by dx, that derivative term dy by dx always we are going to denote by p, and hence we are going to consider the standard notation as dy by dx is equal to p, or p is equal to dy by dx, which is in case of first order and higher degree differential equation. This is the value of dy by dx is p, or p is equal to dy by dx, that is in terms of value, or it is the standard notation. Then by considering dy by dx is equal to p, whatever we have the equation which is in terms of dy by dx, we can write it in terms of p, and hence substituting dy by dx is p, that is a naught into dy by dx p raised to the power n plus a1 into dy by dx is p raised to the power n minus 1 plus, and so on, an is equal to 0, and hence we have the equation 1 is in this form. And hence the equation 1 we have in terms of dy by dx, and equation 2 we have in terms of notation p, and both the equations remain same. Both are the differential equation of first order and higher degree, and hence you see that which equation is called differential equation of first order and higher degree. If the equation involving dy by dx with the higher power, the differential equation which involving dy by dx with the higher power, then it is of first order and higher degree are those differential equations which involving p. Those differential equations which involving p. That equation is always considered as the differential equation of first order and higher degree, and that is the either such type of equation or such type of equation is called the first order and higher degree. That is what type of equation is called differential equation of first order and higher degree. That is one. And that standard notation dy by dx is a p. Then here if we have the differential equation, then always we have to find its solution. Always we have to find its solution. Then to solve the differential equation, there are different methods. There are different methods, and hence in order to solve the differential equation of first order and higher degree, there are four methods. There are four methods. Out of these four methods, the first method is called as equation solvable for p. The first method is called as equation solvable for p. Is first method. Second method is equation solvable for x. Third method is equation solvable for y, and fourth method is called Clairaut's method or Clairaut's equation. These are the four methods. Out of these four methods, firstly we shall discuss the first method as equations solvable for p. Equation solvable for p. Then by using this method, how we can find the solution of given differential equation. And first you remember that when you apply this method, that is equation solvable for p, and we can apply this method only when that the given equation is written as the product of linear factors of p. When we write the given equation as linear factors of p as the product, then we can apply this method, and that is in this method write the given equation into linear factors of p in the form of product. Hence either the equation 1 or equation 2 we have to write as the product of linear factors of p. As a first step. After writing the given equation as the linear factors in p, then the second step is that equate each factor is equal to 0. That is p minus alpha 1 is equal to 0. P minus alpha 2 is equal to 0. Likewise, consider each factor is equal to 0. By considering each factor is equal to 0 which containing p, you replace p by dy by dx. Substitute the value of p is equal to dy by dx. We know p is dy by dx. And by substituting p is equal to dy by dx in each factor, we will get a differential equation of first order and first degree. first degree. Then we have to solve that differential equation of first order and first degree by using the any previous methods. And by solving we will get the solution of that equation. Suppose that the solution of first factor is f1 x y c is 0. Solution of second factor f2 x y c is 0, and so on. Solution of last factor is fn x y c is equal to 0. It means that for each factor we shall get the one solution. And each factor when considered is equal to 0, and by replacing p is equal to dy by dx, we shall have the differential equation of first order with first degree, and by solving we shall give the solution. After knowing the solutions of each factor, what is the solution of given equation? Then the solution of given equation is the product of these solutions. It is f1 xyc into f2 xyc into f3 xyc, and so on is equal to 0. The product of all these solutions is nothing but the solution of given equation. And hence, first to remember that which equation is called first order with higher degree. Those equations which involve dy by dx with the power greater than 1 are those differential equations which involve p called differential equation of first order with higher degree, where p is dy by dx or dy by dx is equal to p. Then there are four methods. Out of these four methods, the first method is that equation solvable for p. Then when do you apply this method? And we can apply this method if the given equation can be written as the product of linear factors of p. If it holds, then we can apply it. Write the equation as a product of linear factors of p. Consider each factor is equal to 0. Replace p by dy by dx. Solve that differential equation. Find the solution, and the required solution is the product of all these solutions. For example, solve the equation dy by dx whole square minus 7 dy by dx plus 10 is equal to 0. Since these equations involving dy by dx means firstly it is the differential equation. Then is it differential equation of first order and first degree? No, because the power of this dy by dx is 2. Power of this dy by dx is 2, means it is not of first order and first degree. And here this dy by dx having the power which is greater than 1, and hence it is of the first order and higher degree. Then to solve the such type of equation, in generally the very first step is that if the given equation is in terms of dy by dx, then first we convert in terms of p. By using this notation, and hence dy by dx is p x square minus 7 into dy by dx is p plus 10 is equal to 0. And hence it is in general very first step is that if the equation is in terms of dy by dx, First, we convert in terms of p with the help of that standard notation is first. Then, here we have the equation. The given equation is p square minus 7p plus 10 is equal to 0. And we have to solve this equation. Then to solve this equation, first to identify it is of which type, and we have identified of higher degree. Higher degree. Then for higher degree there are 4 methods. Out of these 4 methods, you check that which method is possible to apply. Which method is possible to apply. So far we know the one method, equation solvable for p. You try to apply this method, that is p square minus 7p plus 10 is equal to 0. And you check that whether it is possible to write it as product of factors in p, since it is quadratic in p square and p means which is quadratic in p. Then we know how to write the quadratic equation as product of factors. Here find the two factors of 10, that is 4 and 3. 4 and 3. But we require total sum is minus 7. Minus 7 means the two factors of plus 10 are minus 4, minus 3. Minus 4, minus 3, whose sum is minus 7. And hence, it is for this quadratic equation. Now, p is variable, you suppose that, which is quadratic in p, and hence, you can write it as product of factors. The one is p minus 4 into p minus 3 is equal to 0. And hence, the first step is that write the equation as product of linear factors. Product of linear factors. The next step is that consider which factor is equal to 0. Consider first factor, p minus 4 is equal to 0, p minus 3 is equal to 0. That is, consider each factor is equal to 0. The third step is that consider each factor is equal to 0 and replace p by dy by dx. And now, suppose p minus 4 is 0. Now to solve it, substitute the value p is dy by dx. It is going to be dy by dx minus 4 is equal to 0, and it is the differential equation of first order and first degree. And we have to solve this equation by using the previous method. And according to the given equation, here we can easily separate the variables. And hence by multiplying dx to it, dy minus 4 into dx is equal to 0. And check that here we have 4 into dx is equal to 0. And here by multiplying dx, it becomes dy minus 4 dx is equal to 0. And here, whatever we have, this term which is completely functions of y, it is the completely functions of x. And you know the solution is nothing but the integration of differential equation. And hence, after separating the variables, to get the solution, we have to integrate it. Integration of dy is y minus 4, integration of dx is x, plus after integrating we have to add the constant and add plus c to the left hand side, that is equal to 0. It is the solution of this differential equation. Similarly, there is one more factor, second factor, p minus 3 is equal to 0. Consider the second factor, replace p by dy by dx it is the first order and first degree. Separate the variables, multiply by dx, integrate 1 minus 3x plus. You add the same constant. In each solution, you consider the same constant as c is equal to 0. And hence, it is one solution for this equation. This is another solution for this equation. Hence, what is the solution of this given differential equation? And the solution is nothing but the product of all these solutions. Product of all these solutions. The first solution is y minus 4x plus c into the second solution is y minus 3x plus c, that is equal to 0. The products of left hand side is equal to the product of a right hand side. It is going to be the required solution, and hence when we have the power greater than 1 at that time, that equation is going to be higher degree equation. Then if it is in dy by dx, first to convert in terms of p. To solve for p, you write in the form of product of factors. Consider each factor is equal to 0. Replace p by dy by dx. Solve that equation by separating the variables and integrating. We have the solutions. Then the required solution is the product of all these solutions. Consider one more example. Solve the equation p square minus p minus 6 is equal to 0. Since this given equation contains p directly, in generally the very first step is that you have to identify the given equation is of which type. It is in generally the very first step. Then second step is that according to that type of differential equation, you have to choose the correct method. If you fail for these two methods, then it is not possible to get the required solution of the given differential equation. Since this equation involving directly p means it is of first order and higher degree. Then which method we can apply? Out of these four methods, we know only one method, equation solvable for p, and we can apply it only when it should be written as product of factors. P square minus p minus 6, which is again quadratic in p. If it is quadratic, then we can write it as product of factors. Then what are the two factors of minus 6? Whose sum is minus 1, that is minus 3 and 2. Minus 3 into 2, minus 6, minus 3 plus 2 is minus 1. Means we can factorize as p minus 3 into p plus 2 is equal to 0. Means it is possible to write this equation as product of factors. Hence we shall apply that method. And according to that, it is the first step. Then the second step, take each factor is equal to 0. Replace p by dy by dx, which are the differential equation of first order and first degree. Solve it. For solve it, you separate the variables, multiply by dx, multiplied by dx, and it is the separation of variables. Integration of dy is what? Minus 3 into constant. Integration of dx is x plus you add the constant. It is the solution of it. It is the solution of it, and hence the final solution is the product of these factors, that is equal to 0. That is equal to 0, which is the required solution. Next time we shall solve some more example. Hence, first to remember which equation is called differential equation of first order and higher degree. What is the standard notation? Dy by dx is equal to p, and there are 4 methods. Out of these 4 methods, the first one is equation solvable for p. When you apply this method, and what are the steps involved in this method?